What is going on, Calc class? Back here on a Friday edition of Bearded Math. Everyone is super excited. The AP today released a lot of their information about the test that is coming up, so I wrote it out in kind of the most important bits here. So the test day they have decided is May 12th at 2 p.m. for us. It's only going to be a 2-question exam. So it's going to be, the first one's 25 minutes. That you get to read and respond to it, and you have 5 minutes to upload your response. Second question, same deal, except only 15 minutes to read and respond, and then 5 minutes to upload. Some info once you go forward into question 1, or into 2, you can't go back into question 1. So once you're done with the first one, there's no, treading backwards. 60% for question 1, 40% for question 2. And each question, they said, is going to cover 2 different components of calculus, whatever that means. So how are you going to be able to upload your responses? Since they are free response questions and worth like numerous parts, like parts A, B, C, maybe D, you could type in kind of your work and your thought process, or what I would probably recommend is if you have a good camera on your phone, just take a picture of your work, make sure it's nice and neat, and then upload that work as well. As for a calculator, they said you are allowed a calculator, but all work is going to be able to be done with just pencil and paper. My personal suggestion is that you're going to have a 4-function calculator because we're so good at arithmetic, right? That add, subtract, multiply, divide. You have a calculator for that. So when maybe you solve an integral, and it comes down to all those numbers that are sitting there, just plug that in a calculator and you're going to be good to go. Okay, so there's the update with the AP. If they release more practice questions or things like that, we'll go from there. We're going to do one at the end of class today. So the last new thing we actually have to work on is called slope fields. So this is relating to differential equations. For instance, a nice basic differential equation we could have here could be something like dy over dx equals x plus 1. And from here, they could ask us to create the slope field. And it's a field that's your xy axis filled with a bunch of dots at different integer coordinates. So like 0, 1, 1, 1, 2, 3 could be a value, anything like that. And you're going to have to be able to properly fill these in. How these are going to work is you take your xy here, and you just start plugging in different values for x, and that's going to equate to what the slope would be at these certain points. Instead of talking, let's start doing some of them. So if we started at 0, 0, the x value there is 0. What's 0 plus 1? Well, that's going to be 1. So we'd have a slope of 1. So you draw some line through there that has a slope of 1. Okay. You may be thinking, well, isn't this value, all right, that was 0, 0, at 0, 1 here. If you notice, the x value is still 0, so 0 plus 1 is still 1. And in fact, all the values right along the y-axis are going to have a slope of 1 here because all the x values are in fact 1, or 0 there. Ugh. Let's see if I can speak better. If we're moving out 1 here, so at the point 1, 0, the x value is 1. 1 plus 1 here is 2, so the slope here should be 2. So if that's a slope of up 1 over 1, this one needs to be a little bit steeper. And in fact, all of these values here are going to have that same property. So they're all just a little bit steeper. So you're just drawing a line that has a slope of what the number is at those points. And if we go out one more here, this would be 2, 0, 2, 1, 2, 2. All the x values are 2. So if you plug those in, this would get a slope of 3, which is somehow even steeper. And these are getting progressively harder to draw as they become steeper. Let's go to the other side and see what's going on. Here we have the x values are -1. All of these are -1. If you put -1 in here, all of these are going to be 0. So a 0 slope for all of these. And if we go out once more, we're going to get -2 as the x values, giving us a slope of -1. And there's kind of this pattern here that's being formed. Everyone kind of see this little like bowl or U pattern here that's going on. That's there for a reason. Think back to the last lesson we did on solving these. If I took this equation and tried to solve it, the first thing I'm going to do is separate the variables. And that's just going to come down to here. By just multiplying the dx. From here we can integrate both sides. And this side, don't forget dy, there's actually kind of a 1 sitting there. So the antiderivative of that is just going to be y, 1/2 x squared plus x plus some c. So hopefully you can notice here that this is going to be some parabola shape. And notice I said these are all kind of these U shapes. These are parabolas. So in fact, depending on what this c is, the original function is going to be somewhere on here. So for instance, if they gave us a c value, some plus value of like, I don't know, let's say c was 2, then we know that we have the value of 2 up here. And in fact, if we were trying to draw the real graph, it would probably look something like this. Some parabola that goes through the point 0, 2. It's going to correspond there. So that's kind of the connection that's being made between this original equation, the slope field that we then created, and what the original function would look like. Definitely a different thought. Not supposed to get it right away. But let's try doing a couple more. So let's look at dy dx equals x plus y. So here we're adding 2 different variables, not just one variable like the question above. So if we're looking at 2 different ones, I always like starting at the middle. At 0, 0, that's 0 as your x, 0 as your y. Our value here is going to be 0. Okay, let's try going at 1. X is 1, y is 0. That's giving us a slope of 1. X is 2, y is 0. That's giving us a slope of 2. So something a little sharper. Let's go the other way. X is negative 1, y is 0. So I get a negative 1 there, and a negative 2 there. So kind of symmetry going along here. Let's do the same thing going up and down. I always like kind of starting with the axes first. Okay, if we're going up, the y is 1, the x is 0 here, so a slope of 1, and then a slope of 2. If we're going down, y is negative 1, x is 0, negative 2, 0. So a negative slope there. And don't get too caught up in like, it's not quite negative 2, maybe that's negative 3. The big concern is, if we're just free drawing this, is that it's actually going in the negative direction. Okay, let's keep going with some more of these. Let's start up in this quadrant. 1, 1. Our slope is 2. 2, 1, the slope is 3, so that's getting pretty steep. This is also 3. This one's 4, which is getting really steep there. Okay. So hopefully you can see kind of there is some pattern here that's winding. Let's go down here. X is 1, y is negative 1, so this is actually giving us a 0 slope. Okay. 1 and negative 2, that's just giving us a negative 1 slope. And then what do we have? 2 and 1. 2 and negative 1, so we just have a 1 slope. And then 2 and negative 2, we have a 0 slope. Ooh, there's some nicer patterns here. Look at the zeros. And I'm going to hope that continues. Negative 1 and 1, yeah, that's 0. Negative 2 and 2, that one's also 0. So there are patterns that develop here. We have a negative 1 and a positive 2. Negative 2 and a positive 1. So start looking at these slopes to the side. These are all -1 slopes. All +1 slopes. Ooh, that's kind of nice. -1, -1, we have a -2 slope. These are going to be -3, and then a -4. So there is some kind of pattern. It looks like the swirl that's happening here. And if you're thinking, we can't really separate these, because remember, we would be subtracting the y, and we can only multiply or divide them over. So this is a differential equation that we can't write as y equals. So this helps give us a graph of what that function would look like, or that graph would look like. I don't know if it's a function here. And then let's look at one more here. dy over dx is -y over x. So the first thing I'm thinking of is what happens when these values are the same. That's going to be some easy points to plot, hopefully. Right, think 1 over 1, 1, 1. That would normally be 1, but it's negative. So that's going to be a negative, that's going to be a negative, that's going to be a -1, and that's going to be a -1. And they are the same exact value. Notice that this is the middle one here. When x is 0, we in fact don't have a number here because we can't divide by 0. So in fact, for all the x equals 0s, we don't have anything to actually write in. So we just kind of leave those blank here. Let's continue on with maybe the y-axis here. Oh wait, no. This is the one where they're all 0 and we can't write anything in. When the y is 0 here, sorry, on the x-axis, these are all 0. And this vertical one, all the x values are 0, which means we can't actually plug them in. So with these patterns, we actually only have a couple of them left to find. 1, -1 is going to give us a +1 value. 2, -2 is going to give us a +1 value. So these are giving us positives. Okay, patterns are slowly arising here if you're looking at this thing. Let's try 2 and 1. This would be -1/2. So a -1/2 here. About 1 and 2. This is going to be a -2. And then here we have 2, -1, so this is actually a +1/2. This one is going to be a +2. Notice some of the patterns developing on either side. -1 and 2. +2. -2. +1/2. -1/2. So we're slowly developing this kind of pattern here. Okay, let's get on to what an actual AP question would look like. To see what they actually have with slope fields, it's not going to be as complex as kind of what I had here. They're going to give you things maybe a little more easy to identify here. So here's the AP question from 2016, number 4, related to differential equations. They give us this equation here. And for part A, they're going to say, sketch a slope field at the 6 points indicated. And they give us this original equation here. Okay, with this original equation, what we're going to want to be able to do here is just start plugging in the points. So we have 0, 0 as our first point. And at 0, 0, you're going to have space to actually write this stuff out. You're having 0 over 0 minus 1. That's 0. Okay, let's go up 1. 0, 1. So we can put in 0 for the x again, and 1 for the y. This is -1. And then finally, 0, 2. So here, we're having 0 for the x still. This is a -4, which is more significantly slanted. Okay, let's try the other ones. 2, 0. 0 over 2 minus 1, that's 0. And then next we have 2, 1. Slope of 1 there. And then 2, 2. 4 over 2 minus 1, which is 4. And there we go. That's part A of an AP question done. Okay, part B. Let y equals f of x be the particular solution to the given differential equation with f of 1 equal to 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f of 0.7. Okay, let's start off with that. Let's give ourselves a little bit of room here to work with. And they want us to do what again? Write an equation for the line tangent to the graph. So if we're looking for a tangent line, like we've said all year, we need two things. We need a point, and we need a slope. And that's all we're going to need here. For the point, they give us this equation right here. They tell us y equals f of x, and then they give us this. So that means, if we're thinking inside of this, that's the x, that's the y. So our point is 1, 0. Great. Now we need to find the slope. What have we said all year? What is the same thing as slope? Derivative. So, if we're looking for that, that's really the same thing as saying we want dy over dx, which thankfully for us here, we have right there. Okay. We now have this point, so we can plug in 1, 0 and see what we're going to get there. Write an equation for the line. Notice when we plug in the 1 here, though. Did I do this one right? I'm going to look at the end and see if I mess this up or not. Which means we would have no slope. I'm questioning. Let me look this one up. Give me one little bit here. This is why you should probably look ahead before just doing these on the fly. So I said this is 2016, number 4. Oh, did I write down the wrong stuff in here? Oh, good. I definitely did. Yep, I just wrote down the wrong equation. So let's scratch a bit of this. So what the numbers are actually supposed to be. Good job by checking this mid-video. And I'm not going to stop and edit. It said 2, 3 here, and the number was 2.1. So let's scratch this. And this was 2, 3. I think everything else I did okay. At x equals 2. Sorry, guys. Okay. Good thing I caught it now instead of going through and having it be completely wrong. So we're looking for 2, 3 as the value here. So it is y squared over x minus 1. So here we would have 9, which is from the 3 squared over 2 minus 1. So our slope here is 9. And that was our general equation. So y minus our y value here was 3 equals 9 x minus 2. And that would be our equation of the tangent line. Remember, they also wanted us to approximate 2.1. So how we can approximate 2.1 here is you take this equation and put in 2.1 for x. So what that's going to look like, y equals 9 times 2.1 minus 2 plus 3. I've added the 3 over, 2.1's in there. Y equals 9 times 0.1 plus 3. Y equals 0.9 plus 3. Y equals 3.9. That would be the approximation, or what f of 2.1 would equal. Okay, last part of this one, and I'm going to have to adjust this that I wrote out too, because I made that same mistake. So we want to find the particular solution not at 1, 0, but we want it at 2, 3. And this is what we were doing on Monday that we learned. So we have our differential equation here. Let's separate the variables, not cross multiply. So we have a 1 over y squared here. We have a 1 over x minus 1. And we're going to try to find the antiderivative of both of these sides. This one is probably the easier one, negative y to the negative 1. This side you might need to go through and do a u substitution. If you did do that, you would notice it's the same thing as 1 over u du. This becomes ln of u plus c. But remember, we were in x world, so we need and we're close. Let's rewrite this. At this point, I would probably advise putting in our values here, 2 and 3, to find out what this specific c is. So this is where we have to remember which one's x, which one's y. So for the y, it's a 3. Ooh, ln of 2 minus 1, that's good. That's just 0. So we have c equals negative 1/3. So we could plug that back in to our equation up here. But if you're reading the question up top, they want the solution as y equals f of x. So we could kind of cross multiply here, getting y equals negative 1 all over ln of x minus 1 minus 1/3. And I think that is our solution here. Yeah. Right, if you're stuck there on that cross multiplying, think all over 1. They can pretty much switch. Okay, let's give a quick point breakdown of how this actually works on the AP. For that first question where we were graphing all these points, it's worth 2 points. You get 1 point for the zeros, so these two, 1 point for the others. So this was a 2-point question. Next one, the one where I started this wonderful typo. You get 1 point for the correct tangent line here, 1 point for the correct approximation. So another 2-point question. And AP questions are all out of 9, at least they traditionally are. I don't know what they're going to be this year. On this one now, how the point breakdown typically goes is you get 1 point for successfully separating variables, 1 point for each correct antiderivative. So we're up to 3 points just getting to this step. They give us 1 point for finding the constant, and then 1 for solving, for a total of 5 points here from the stuff we did on Monday. Okay, This went a little longer than I thought. Hopefully it's not too overwhelming. If it is, at least you have the video to go back to. And only about 90 seconds of it is wasted from me running to see what my problem was. Homework here. So I'm going to want you to do question 6 from the 2018 AP exam and question 4 from the 2015. I'm going to send the link in the description below. Try these questions first. Give yourself about 15 minutes. Then try looking at the answers. The page I'm going to link you to has all the AP tests from like the past, I don't know, 15 or so years, except for some reason 2019, which is on like an adjoining page. It's not hard to find. It also has all the solutions. Try the questions on your own first. Don't just look at the solution and say, oh, I did it. Look how smart I am. 2015 is slightly different. This is going to be almost identical to what we just did. This one's slightly different and may be a little confusing at first. Try to push through. Okay, I'm going to post another video, I'm going to say on Monday. Have a great weekend, guys. Stay safe, stay healthy. See ya.